Cool, so I guess we've had a look at some more basic worked examples in just the past couple of minutes, so I guess maybe it's time now for some more difficult ones. Let's check them out.
Alright, so we're going to have a look at a couple of harder questions now. So we've got 5 to the power of 4m plus 3 multiplied by 125 to the power of m minus 2 is equal to 25. So when you're looking at this, hopefully there's a couple of alarm bells ringing saying that what we want to do is actually change all of these to a base of 5, because you can use 125, that could be 5 to the power of something is 125, and 5 to the power of something is at 25. So let's go through and figure out what those somethings are. So we're going to rewrite this as 5 to the power of 4m plus 3 multiplied by 5 to the power of what gets us 125, well it's going to be 3, and we'll do that in brackets, and write n minus 2 outside like this. And 5 to the power of what gets us 25, well it's going to be 5 to the power of 2. So now what we can do is go through and expand these brackets here, so you get 5 to the power of 4m plus 3, we'll just leave that as is, multiplied by 5 to the power of 3 times n is 3n, and 3 times negative 2 is negative 6, is equal to 5 to the power of 2. Now what I can do is combine these two terms here, so that means I've got 5 to the power of 4n plus 3 times 5 to the power of 3n minus 1, so what I need to do is combine them by adding the actual powers, so that's going to get us 5 to the power of 4n plus 3, and then I'm going to add 3n minus 6, all of it that is, and that's going to be equal to 5 squared. So when I add these now, what I'm going to get is 5 to the power of 4n plus 3n is 7n, and 3 plus negative 6 is negative 3, is equal to 5 to the power of 2. So now what I can do is just get rid of these 5s, just pretend they're not there really, and just equate the powers. So that means I get 7n minus 3 is equal to 2. So now what I need to do is add 3 to both sides, so that gets me 7n is equal to 5, and now divide both sides by 7 gets me n is equal to 5 over 7, like so. Now we're going to have a look at part B, where it says 5 to the power of 2x minus 4 times 5 to the power of x minus 5 is equal to 0. Now this one's a little bit harder because we've got a couple of repeated things here, and it's not as straightforward as what we've actually been looking at before. So what we're going to do is we're actually going to put this in brackets here. We're going to write 5 to the power of x, and then we're going to write squared like that, minus 4, 5 to the power of x minus 5 is equal to 0. Now what you can see here is we've got 5 to the power of x squared, so that's going to be the same if I went through and expanded it once again, but the reason I've done that is I'm rigging the question so that way I can actually go through and solve it easier. Because what I can do now is, as you can see here, you've got your 5 to the power of x is actually repeated. So if we have a look here, 5 to the power of x and 5 to the power of x, what I can do now is actually substitute that for smiley face, as I've done in previous chapters. So I get smiley face squared minus 4 smiley face minus 5 is equal to 0. So as you can see here, this is just basically a quadratic equation, isn't it? So what I need to do is just go through and factorize in order to be able to solve. So in order to do that, I need to look at the factors of negative 5 that will add to negative 4. Now the factors of negative 5 are 1 and negative 5, and negative 1 and 5. So what ones are going to add up to negative 4? Well, it's going to be 1 plus negative 5. So that's going to get me smiley face plus 1, and smiley face minus 5, like so, is equal to 0. So now when I solve, I'm going to get smiley face plus 1 is equal to 0, and smiley face minus 5 is equal to 0. Now I can go through and substitute back in for smiley face. So we knew that 5 to the power of x was equal to smiley face, so therefore 5 to the power of x plus 1 is equal to 0, and 5 to the power of x minus 5 is equal to 0. Now if I've got 5 to the power of x plus 1 is equal to 0, what I need to do is go 5 to the power of x is equal to negative 1, and 5 to the power of x is going to be equal to 5 when I add 5 to both sides. Now let's try and equate the powers. So if I think about this for a second, there's not actually any way that I can get 5 to the power of anything is equal to negative 1. There's not actually any possible combination. If it was 1, I could say 5 to the power of 0 is equal to 1, but the negative makes it impossible to do. So therefore, 5 to the power of x equals negative 1 has no solutions. Whereas 5 to the power of x, well that's going to be the same as saying 5 to the power of 1. So therefore, x is equal to 1. So in summing up, essentially, we know that x is equal to 1 for this solution. That's the only possible answer there could be, because 5 to the power of x is equal to negative 1 has no solutions. Alright, so it's now time to press pause and attempt the following questions. These are: solve the following indicial equations. 81 to the power of 2 minus x divided by 27 to the power of x plus 3 is equal to 9 to the power of 2x. And in part B, 2 to the power of 2x minus 6 times 2 to the power of x plus 8 is equal to 0. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back guys. Now the very first thing I did for this question in part A was 81 to the power of 2 minus x, 27 to the power of x plus 3 is equal to 9 to the power of 2x, was I had to look through and figure out what the base was going to be. Now if you thought 9, well you're pretty close because of course you could use 9 for your 81 and your 9, but it won't work for 27. So that means we can only use a base of 3 for each one of these because we want to keep them all the same. So that's what I've done there. Now 3 to the power of what will get me 81? Well it's 3 to the power of 4. 3 to the power of what will get me 27? Well, it's 3 to the power of 3. And 3 to the power of what will get me 9? Well, it's 3 squared. So what I've done here is I've written all of those in the brackets and left it with the original powers. So you've got 3 to the power of 4 is equal to 81. So you get 3 to the power of 4 bracket 2 minus x, because it's the same thing as what you can see up there, just written differently with the different bases. And I've got 3 to the power of 3 all in brackets to the power of x plus 3, and 3 to the power of 2 all in brackets to the power of 2 to x. So the next thing I need to do now is go through and expand these powers. And in order to do that, what I need to do is go 4 times 2, well that's going to be 8, 4 times negative x is negative 4x, 3 times x is 3x, 3 times 3 is 9, and of course 2 times 2x is 4x. So you get 3 to the power of 8 minus 4x divided by 3 to the power of 3x plus 9 is equal to 3 to the power of 4x. Now because I've got a division happening here, what I need to do is subtract the powers because I've got the same base. So I get 3 to the power of 8 minus 4x, and then I subtract 3x plus 9. So that gets me 3 to the power of 8 minus 4x minus 3x plus 9 in brackets, because I'm subtracting the whole power here. Now when I do that, I need to do this and put the negative to both the powers there that you can see. So I get 8 minus 4x, subtract 3x, and subtract 9. So you get 3 to the power of 8 minus 4x minus 3x minus 9 is equal to 3 to the power of 4x. So now what I need to do is go through and collect like terms. So you go 8 minus 9 is negative 1, and negative 4x minus 3x is negative 7x. So you get 3 to the power of negative 1 minus 7x is equal to 3 to the power of 4x. Now if we have a look here, I've got my same bases of 3, so I can pretty much just get rid of them and rewrite the equation as negative 1 minus 7x up here is equal to 4x. Now if I add 7x to both sides, so let's go through and do that. I add 7x like so, and I add 7x over here. That's going to cancel out, leaving me with negative 1 is equal to 11x. And of course, therefore, x is equal to negative 1 over 11. Now for part B, what I've got is 2 to the power of 2x minus 6, bracket 2 to the power of x plus a is equal to 0. So what I needed to recognise was that I could actually rewrite 2 to the power of 2x as being 2 to the power of x in brackets squared, minus 6 times 2 to the power of x, plus 8 equals 0. Now when you see these 2 to the power of x's, what I can do is substitute smiley face in, and recognising that this here is actually quadratic. So what I get then is smiley face squared minus 6 smiley face plus 8 is equal to 0. Now because it's a quadratic, I need to look for the factors of 8 that add to negative 6. So what are the factors of 8? Well, it's going to be 1 and 8, 2 and 4, and that's it, but it's going to be negative 6, so it means both of these have to be negatives here. So negative 1 minus 8 is equal to negative 9, so that's not going to work. But negative 2 minus 4, well that's negative 6. So what I'm going to write here is smiley face minus 2 and smiley face minus 4. So you get smiley face minus 4 is equal to 0, and smiley face minus 2 is equal to 0. So instead of writing smiley face, what we're going to do is substitute back in 2 to the power of x. So you get 2 to the power of x minus 4 is equal to 0, and 2 to the power of x minus 2 is equal to 0. Now let's just go through and solve this one first. 2 to the power of x minus 4 is equal to 0, so you go 2 to the power of x is equal to 4 when you add 4 to both sides, and 2 to the power of x is equal to 2 to the power of 2, because 4 is the same as saying 2 to the power of 2. So what we need to do now is just get rid of these bases, so the 2's are basically the same here, so we can just say x is equal to 2. For this one now, over here, you've got 2 to the power of x minus 2 is equal to 0, so you add 2 to both sides, giving us 2 to the power of x is equal to 2, and 2 of course is the same as saying 2 to the power of 1, so when we get rid of the bases here, you can just say that x is equal to 1. So therefore, for this equation here, if you substitute in x equals 2 or x equals 1, you'll get an answer of 0.
Alright guys, so thank you very much for tuning into today's lesson, which was all about solving indicial equations. Now hopefully you realise it's as simple as 1, 2, 3. That's right, the very first step we need to go through and do is rewrite the equation. Then we write both sides of the equal sign to the same base. And then in the last step what we need to do is go through and equate the bases, making sure we solve for x that way. Now of course, like always, make sure you stay tuned for the very next lesson. And of course, say hi to your maths teacher for me. Wazzy out.